So we do have an introduction from Rahman from Crypto Job List. He will just give you a quick introduction about what Crypto Job List is about.
Thanks. Hey everyone, just also one of the event supporters as well. Just wanted to share a few words about what I'm working on. How do we get this? There we go. Awesome. Yeah, maybe you have seen the site, maybe you haven't. If you guys are running a company in blockchain space, or you're a developer, or you're a non-tech person who is interested in working in blockchain, I run this site, Crypto Jobs List. So you can come over, subscribe to the newsletter. We have a fantastic Telegram group and chat and chatbot as well. Yeah, and there's like a gazillion of positions that you might be interested in, remote ones, ton of features, some familiar companies that you already know, all over the world basically, a lot of in Singapore as well. So if we, hold on, how do I, come on, a few more pixels, there we go. Let's give it a try to Singapore. There we go, a few positions in Singapore, some companies that you already know. All right, cool. So that's me, Ramon. If you want to connect with me, reach out to me on Twitter or to that chat box. Thanks. Thank you.
Thanks. Thank you, Rahman. Okay, next we will have MING Labs. So MING Labs, yeah, it's gonna give you an introduction.
Hi everybody, thank you so much for coming on. We are minglabs.com. We are a digital business builder for technology, so we make complex technology accessible to the everyday user. And I think when we build for technology, sometimes we forget that at the end of the day, what we want is mass adoption. We want people to be able to understand how to use it. It's about a product. And I mean, today we're having a really technical discussion, and we support that because we help people like you access the mass consumers or the users that you want in the future. So if you have any interest in that, come talk to us, we're here. That's our website. And we also really want to thank our supporters Wantedly. So Rahman from Crypto Jobs List is one of our community members, but we also have the good people of Wantedly. They're a social hiring platform. So if you're a developer and you're also looking for tips on how to get a job, or looking for how to make the best use of your time as a developer, you can talk to them and also to Rahman. So thank you very much, Wantedly. Thank you for Crypto Jobs List.
Next we'll have Dylan, and he'll be covering Ethereum, Bitcoin, APIs.
Okay, this is me. So, hi, welcome blockchain people to Singapore. And it's a really nice meetup, and we have so much to eat, and we have beers as well in the meetup. So especially, so thank you for giving me the chance to present here about Ethereum, Bitcoin, and things what I do in my workplace and things what I do in my leisure time. So this presentation is about kind of technical for the people who already have the experience with programming and as well as development, who are willing to start their discovery for the blockchain stuff or as cryptocurrency stuff. So this will be a good presentation for them to start their career with cryptocurrency and the things that we are moving forward. And I'm Dilum Nawanjana, and this is my GitHub and this is my Twitter. If you have any questions about this presentation, just tweet me after this presentation. I will reply you. And even though I am working in Singapore, I am from this little South Asian island country called Sri Lanka. Hope at least few of you know about Sri Lanka. And in Sri Lanka, we have nice beaches and we have tea plantations, and especially we have elephants. So I'm a core team member of Celluloid. Celluloid, if you don't know about Celluloid, Celluloid is a Ruby concurrency and parallel processing third-party gem. So I'm a coding member of Celluloid, working with Celluloid closely and going around Asia giving talks about mainly Ruby, but this is about cryptocurrency. And according to the founder of Ruby, I'm a Rubyist. And here in Singapore, I'm working in a startup called BBytes, and mainly we are working with Ruby, and most of our APIs are based on Ruby, and as well as, most importantly, we are working with blockchain stuff, private blockchains like Blockchain&Dapps, and as well as Ethereum, Bitcoin, those kind of stuff. And we are hiring any blockchain developers who have experience, we are hiring as well. So I will be here after this presentation and after this meetup, roaming around. If you are looking for a job in development of the blockchain stuff, we would like to hear from you. And also, right now we have already launched an ICO called BigTK.io. If you are familiar with, if you want to have a look, just go there. That's it. And this presentation is kind of technical. Most of the things are technical. I'm talking about the APIs and not going deep into the blockchain stuff, but technical stuff will be there most of the time. So even though this is a technical presentation, I'm not going to define what is cryptocurrency here, or else what is Bitcoin, or else what is Ethereum, because it's too mainstream. Just go Google and just search for what is cryptocurrency and Bitcoin and Ethereum if you want. But as I see what is blockchain, I will explain what I think is a blockchain as I think. As I think blockchain, if you remember, when we were in college, we studied about linked list, data structure, which has a head node, and then following up there will be nodes going one by one, and the end node will be pointing to a null. That's how we know the linked list is over. So this is a Bitcoin, this is Bitcoin blockchain example. We have blocks in Bitcoin, and each block is pointing to the previous block. So, which is kind of similar for this implementation. It's not like 100% similar to linked list, but so I would prefer to define blockchain as a data structure, other than people saying it's a database, or else people say it is not a database, it is kind of a database. It has some similarities, but for me as developers, blockchain is a data structure which is kind of similar to linked list, but more complex than linked list. As you can see in this Bitcoin blockchain, in a block, we can see there are multiple transactions in a block. So earlier in the implementations, in the early days in 2009 to 2010, 11, there were around 20 to 30 transactions per block in Bitcoin, but right now it is over 2,000 per block, the transactions, number of transactions. So I will talk these things later. So as developers, we love APIs. So when we, first of all, when we try to learn new things, new technology, the first thing that we would like to learn is, are there any exposed APIs in this technology that we can use in our existing platform or else existing application? So that's also what I did when I first researched about blockchain stuff or else Ethereum, Bitcoin stuff. So then I found out all cryptocurrencies I checked have APIs exposed APIs means there are RPC APIs exposed, and then they work from their nodes or else their daemons. So to consume those APIs, RPC APIs, we need a node up and running. For testing purposes, I preferred using a Docker container with a node up and running inside that container, so that I don't need to care about my laptop and I don't need to use my laptop implementations for anything. So everything that I do with this testing or else development things, I prefer to do with Docker containers. So for Bitcoin, I created this Docker container which run inside this container. There will be a Bitcoin daemon up and running, and I can connect to a testing network or else the main network by passing a parameter. So using that, I can start syncing up with the Bitcoin from this container. And then if I created this Ethereum container, inside this Ethereum container, we can run Ethereum node inside there, and then from my host machine, I can connect to this container and use those APIs. So those are the two things I did after I realized there are RPC APIs. Or else, if you want, you can run your own daemons in your personal laptop or else personal machine. So then, once you successfully up and running your node, you have to do is you have to just it's simple as running a curl post command with the correct host URL as well as with the port correctly. So it's as simple as that. So for Ethereum, they have inter-process communication as well as most procedure calls. They call it IPC and RPC. Most of the Ethereum developers and the core organization members prefer you using IPC inter-process communication because it's more secure than RPC. In Bitcoin, you have remote procedure calls. Like Ethereum as well, which you can consume as simple as REST API. This is the Bitcoin RPC API documentation. If you want to check, just Google this Bitcoin RPC API. There will be a documentation with all the API requirements, all the parameters, and everything that you need to pass for this parameter to consume those APIs. So this is more, so whatever the GUI Bitcoin applications do, you can do using these RPC APIs. So like creating wallets or else unlock your wallet and send transactions, check transactions, everything using these APIs in Bitcoin. So for the Ethereum, yes, Ethereum also have their RPC APIs. So this is for the common API, this is the documentation. This is for the common APIs that you can use. And for those common APIs, you don't need to unlock your wallet. Like you can consume those API methods like get block by hash. If you know the block hash, then you can get the block information of this Ethereum block using this hash, and as well as if you know the transaction hash, then you can get the transaction details, who is the sender, who is the receiver, what's the amount transferred and everything in this API. And then you can get accounts, how many accounts are there inside this node, and as well as what are the wallet IDs for these accounts. And also you can get wallet balances using those APIs. So this is the documentation, official documentation for this get balance. You have to pass the parameters of wallet ID and as well as the parameter. The next parameter, the second parameter is if you want to check the balance of the latest or else pending, those kind of things. So it's simple as that. And these are the Ethereum management APIs which you can use for some wallet related stuff for your implementations, like unlock your wallet, or else lock your wallet, or else create a new wallet, or else send a transaction. But for the sending transaction, you have to first of all call this unlock your wallet, and then only you can send call this send transaction method in this API. Otherwise, it will not get verified. You cannot actually do the transaction because your wallet is not unlocked. So this is the way that you can unlock your account, unlock your wallet. So you have to pass your wallet ID and as well as the passphrase, and then how many seconds you will need to be this wallet unlocked. Default it is 300 seconds, but you can reduce that amount to like 30 seconds or something like that. So after 30 seconds, this wallet will be automatically locked again. So because I love Ruby, this is just a REST API implementation, this RPC. So I created this gem, we call third-party tools as gems in Ruby. I created this gem called El Chapo. So the name El Chapo is coming because of one day I can come to a meetup or else conference like this and say I'm the creator of El Chapo. So that's how this name came from. So this is the implementation that I did called El Chapo, and in Ruby you have to just create a new HTTP Bitcoin. If you want to connect to Bitcoin, just create a Bitcoin HTTP connection object with passing the parameter as the host URL with the code and as well as the username and the password of this Bitcoin node. That's it. Then you can use these methods that I previously described to you as methods with this BTC client. So that's it. So then I managed to connect to my node correctly. So on a weekend I was so bored. Then I had nothing to do. I had no plans. So after this slide, I will go through some funny stuff that I did by connecting to my Bitcoin node and the things that I did. Really crazy stuff. I found out about Bitcoin transactions after doing this. So on this weekend, I had no plans and I was so bored, and I already implemented this gem called El Chapo for my workplace things, and I open sourced that. Then I wanted to do something interesting, and I got the idea of converting blockchain to SQL format. So then I narrowed it down to convert blockchain transactions to MySQL database. So this is my intention for that few months ago, that weekend, to write a script to convert all Bitcoin transactions to MySQL format. So I wanted to do that because then I can easily query my Bitcoin transactions inside this MySQL database. Otherwise I had to go through all the blocks one by one and all the transactions, and yeah, it was not easy. Then what I did was I wrote a script to iterate through the blocks from 0 to 500k plus right now in Bitcoin. And this is an example that I am getting for a Bitcoin block, for the Bitcoin block. There's a hash for the Bitcoin block hash, and then you can see there are so many transaction hashes as an array. so I can get those information one by one. So then what I do is I get this transaction ID and I get this transaction raw details of this transaction. With this information I get who is the sender, who is the receiver, and what else? What's the value that that this transaction transferred from the sender to receiver, and those kind of information. So I wrote this Ruby script I used Active Record to connect to my MySQL database, and this is a simple screenshot of this database. I had the block ID and the transaction ID and the block hash, most importantly the value of the transaction happened, and the created date, that means the transaction happened date, sender, receiver, those kind of information. So initially I thought it will be around maximum 5 days to convert all those transactions, but I was wrong. So for like last 2 months, in one of my office laptop, I was running this script for like last 2 months. So today when I checked, I passed 500k block, and I still need about 3 to 4 days to finish my all transactions. I hope there are right now about 500 block number, and just checking the blocks explorer, you will not believe this value. Is for almost 500k bitcoins transferred on that day in this block from someone, I don't know. So this is the transaction. You can see this is the value that transferred in that day from one wallet to another wallet. This is the question that I have. So who else in 2011 have more than like almost about 500k bitcoins in his single wallet? So if one bitcoin is, I think this value is not too accurate, but if one bitcoin is around 18,000 Singapore dollars, that amount that transferred on that day is about 8-9 billion Singapore dollar worth. Yes. So that in that time, yeah. Actually, I think it's about $2 million. Yeah, at that time. Yeah, but right now it is like at least 5 billion Singapore dollars worth. So if we translate it right now in these days. So yeah, that's it. Any question about my database or else any implementation? If you want my database, I am totally okay to give it to you, but right now I don't have the database. I hope it will be around at least 20 GB. Yeah, any questions? No, actually there's no specific reason, because I like to work with Ruby. That's the first reason that I developed this script, and as well as this Ruby gem, and as well as my intention was Ruby is far behind with the cryptocurrency world comparing to Python, Go and everything. So that's why I wanted to do something, and I wanted to contribute to this Ruby community, and I wanted to at least take some steps to go ahead with Ruby with this crypto and blockchain stuff. That's why I chose Ruby as a Ruby, one of the 40 member of the celluloid. So that's the reason. But I know it's not the fastest. It's not. Yeah, I agree, but I wanted to contribute to Ruby community. That's why I preferred to create this gem, and as well as for this script in Ruby. Yeah. Thank you. Yeah.
Why is the import so slow? I mean, 20 gigabytes is a lot, but it's not that much.
I realized after like 1 week, 2 weeks of running this script, there's no nothing wrong with my database connection and saving inside my database connection, but I had some problems with connecting to my daemon and then calling this API and getting information. That's the slowest part, which I couldn't handle. I couldn't do much about that. So that HTTP connection is not too fast for me to like get all the transactions one by one and then check for the transactions and everything. That's the reason this script went for like 2 months and still continuing and continuing. Yeah.
So I see that we have a lot of burning questions, which is fantastic. But we'll have a Q&A session and a panel discussion very towards the end. Just in the interest of timing, we'll have Kide from Exchange Union to have a talk about atomic swaps.
All right, let's start. Exchange Union. Before I deep dive into the technology part, I would like to give you an overview of what we actually do so you can put it a little bit more in context, why we are so excited about payment channels and why we are so excited about atomic swaps. So let's have a look at the digital asset markets nowadays. So frankly speaking, we had to update the slide basically every time we are doing a presentation because more than 1,500 digital assets at the moment, according to CoinMarketCap. Total valuation of total market cap of more than 400 billion and a crazy 24-hour trading volume of more than 17 billion. And all around the world, we're looking at more than 100 digital asset exchanges, which are distributed all over the world, mainly being in Asia, Europe, and also in North America. But we noticed that this industry actually is facing a couple of pain points. So exchanges usually are located in a jurisdiction, in a country, which makes them somehow localized and isolated. So usually they only support one or a couple of fiat currency pairs, like USD, for example, or euros, and they have limited trading pairs. So there's virtually no exchange out there which has all trading pairs. And this is mainly because it is a really hard job, if you have worked in the exchange industry before, to maintain liquidity. So you can't just like switch a currency pair live and expect people to trade it. There has to be a certain liquidity, a certain volume going on in this trading pair. Otherwise, there's simply no incentive to trade. And for users, on the other hand, they see different prices on different exchanges in different markets. So the price on GDAX or Kraken in the US might be totally different from a price that we're seeing on, I don't know, on BitHump or on Coin1 in Korea or in Japan. And in order to leverage that or overcome that, they have to have multiple accounts in place, have to have them KYC'd, and then transfer their assets in between the exchanges. This is called arbitrage. I think for a lot of you guys, this is not a new thing. So people are basically exploiting the fact that there are different prices in different markets. But at the moment, this is a very, very manual and a very cumbersome process. And also, it's very inefficient and costly because in order to transfer funds from exchange A to exchange B, I have to go via the public blockchain, which is slow and very expensive. For example, in peak times, in the case of Bitcoin. Okay, let's jump in. A use case. How does it look like with Exchange Union? So we have exchanges, A, B, C, and D, and they are connected through Exchange Union. And all of them have different locally traded currency pairs. For example, here we have BTC, we have LTC, Zcash, Monero, and we have Dash and LTC over here. And all of these exchanges now, with Exchange Union, maintain a local order book, which gives them a global view of all orders of the other exchanges. Meaning all exchanges are now aware of the orders of the other exchanges. Okay, let's do a sample trade. We have Alice. Alice is a user of Exchange A. At the moment, Alice has 2 BTC and 100 ETC, but now she wants to buy 10 LTC. but LTC is not traded on her exchange A. So what she does is, she inputs an order, for example, say buy 10 LTC using my ETC. This is a market order. And then Exchange Union takes care to find the best price over all exchanges which are connected in Exchange Union. In this case, it's Bob on Exchange C, which is willing to trade 10 LTC for 20 ETC. And in the next second crucial step, after this order got matched, the order information got matched, what Exchange Union does, it transfers the actual values between the exchanges. So it transfers 20 ETC from Alice's wallet in Exchange A to Bob's wallet in Exchange C, and 10 LTC from Bob's wallet to Alice's wallet in Exchange A in real time for each trade in the background. The trade completes, and Alice is very happy. She now owns 10 LTC in her wallet and 20 ETC less. All right, and also a quick overview of why we think this is a pretty cool idea, because actually it benefits both. It benefits exchanges and the users. So exchanges in general benefit from access to a larger user base. So they have virtual access to all users of all other exchanges as well. And the main pain point, especially from smaller exchanges, so if you're starting a new exchange, for example, your main pain point is you don't have liquidity, you don't have volume. And Exchange Union gives you access to the combined liquidity of the overall network. And for larger exchanges, which already have a decent liquidity, we took care to design the fee model in a way that we increase their revenue. In detail, in particular, this takes care that they can maintain their current trading fee. So they are allowed, or they are eligible to maintain their full maker-taker fee like they just have right now. And additionally, we use XUC of the token to award exchanges which provide liquidity to the network. So if I'm a large exchange, like for example Bithumb or Kraken or GDAX, and I would say, okay, my USP is my liquidity, that's why I have users, I now get rewarded if I choose to input this liquidity into the network. And in general, our system is a robust system because we designed it in a decentralized way and in a trustless way. And for users, goes without saying, I see an order book which covers orders of all exchanges combined, so I have a very tight spread. And we have something what we call the best price guarantee. So by being aware of all other orders of all other exchanges, it automatically selects the best price in the order book, no matter if it's on my local exchange or on any of the other exchanges in Exchange Union, and then my trade gets executed on whichever exchange can offer me the cheapest price. And also, my exchange now can offer me new trading pairs. Trading pairs it was not able to offer me before because there was simply no liquidity or little chance of having liquidity. And the best thing, I don't have to have multiple accounts. I can stick with my GDAX interface. I don't have to move anywhere else. Everything is operable for me as a user from my account that I'm used to. So our vision is to be the first decentralized network which enables instant and trustless trades between digital asset exchanges. All right, so what do? We developed a software. We call it the XU node, and it's 100% open source and for free. So one of our main tasks at the moment, by the way, you guys don't have to take pictures if you don't want to, because we really live open source. So just go to github.com/exchangeunion. You will find these slides. Just want to jump in right now, so you, yeah, exactly. So you will find these slides on the internet. There's no need to take pictures, but you can take pictures of it. All right, so we really live open source. So at the moment, our main task actually is to build an actual open source developer community. And this is the very reason why we're doing events like this today, to connect with the community in different locations all over the world, and also excite people about our project. And something that came up like a while ago actually was like, okay, open source is pretty cool, exists since a while, since Linux basically, I would say Linux really made open source popular, but not that popular. So Linux developer was, let's say, it was a geek, that was very convinced of what he or she was doing, and it was like more for the cause of, like for the greater good of contributing to the code base of any Linux system. We have the feeling with Bitcoin this changed a little bit. With Bitcoin, for the first time in history, open source actually pays back. For the first time in history, it is the case when I contribute to a project like Bitcoin and I hold a token that is attached to this project, and my code contribution leads to an increase of value, makes the system, the ecosystem better, the token price increases, and I get paid back. So if you look at all the early day Bitcoin developers and a couple of people also from Ethereum, they always say, Bitcoin took care of me, so now I will take care of Bitcoin, in a financial sense. And this inspired us and said, okay, we want to leverage this with Exchange Union as well. And that's why we decided to use our token to actually award developers which contribute to our code base. So we really do it, at least in the beginning, we see how it goes. We award developers which do a code contribution and meets a certain quality standard directly with a payment of XUC. So this is how we want to monetary-wise incentivize people to actually contribute to our project. Let's see how it goes. Feel free to give feedback. So this is how we start right now. It's in its infancy still, and we still have to streamline our process a bit. But this is the basic idea behind our new open source approach. All right, let's get into technology. Basically, Exchange Union leverages 3 key technologies. Number 1 being payment channels. So payment channels are the very technology which enable an instant transfer between 2 parties of the actual asset. That means real Bitcoin, real Litecoin, real Ethereum. Atomic swaps, number 2, which enable trustless trades between 2 parties, in our case, 2 exchanges. That means if I exchange an asset A against an asset B with a counterparty, I don't have to trust this counterparty. And technology number 3, decentralized order books. So that's a problem of current decentralized exchanges, like for example EtherDelta or everything that's based on ZeroX project, for example, that the order book information itself is not decentralized, which is a vulnerability in terms of it can be attacked, it can be shut down, single point of failure. Okay, let's start with number 1, payment channels. Quick recap, how does it look at the moment? I already talked about that. At the moment it's perfectly possible to transfer funds between 2 exchanges and do arbitrage. How does that work in practice? I'm a user on exchange A and I see, wow, the price on exchange B is cheaper. So what I do is, okay, I have an account in place, I have a KYC account here on exchange B in place. So I go, for example, my Litecoin, we have the public Litecoin blockchain, transfer them over into my wallet of exchange B. Best case, in a couple of, what is Litecoin, the confirmation, the recommended confirmations, I guess like 10 minutes, 20 minutes, I get my funds confirmed on exchange B, I have them there, and then I can start trading with it. Most likely, the price is already gone by then. Okay. Why does it take so long? And also, why is there this hefty fee involved? Because blockchains follow one basic principle. It's called broadcast to everyone. That means, and I use an analogy here from a soccer arena in the 1990s, if I send a transaction on the Litecoin blockchain, everybody has to know about it. Everybody has to look at it, validate it, and agree on it, consensus, into a block. Just like in a soccer arena in the 1990s when there was an important message for Mr. Smith that his wife has gone into labor, which would be announced via the public loudspeaker, because there was simply no way to direct this message only to Mr. Smith. So Mr. Smith knew about it now, but everyone else as well. So this is the principle blockchains follow. Not so with payment channels. By the way, if I talk about payment channels, who knows what payment channels are? Who has a rough idea, payment channels, what I'm talking about? Rough idea? Nobody? Come on. Roughly, okay. Who has heard about the Lightning Network? All right, we're talking about the Lightning Network and the Raiden Network. So payment channel is just another more generic expression for the Lightning and the Raiden Network. In general, payment channels are an old idea. Just a quick recap. Satoshi obviously himself already came up with the basic principle of what payment channels are. So he described it as a transaction that can be updated upon agreement between the two parties, basically infinitely. And this will enable high frequency trades. So the basic principle for payment channels already came from Satoshi himself. How do they work? Okay, in our case we have exchange A and exchange B. And now they go and create a special wallet. And this special wallet is controlled by A and B. I first go through, by the way, in a high-level overview, and then we go into the nasty details. So both of them create a wallet which is controlled by both of them, A and B. So every fund, like all funds in this wallet, need signatures of A and B in order to be able to be spent. And then they deposit funds into it. So in this case, we have exchange A deciding to deposit 100 LTC, and exchange B is not so sure about it, so doesn't deposit anything. And then a magic occurs and a payment channel is opened. So literally the 100 LTC got taken out of the public Litecoin blockchain and put into the payment channel, released into the payment channel. What a payment channel basically does, it keeps track of the balances on each side. So now, for starters, we have exchange A has a balance of 100 LTC, and exchange B has a balance of 0 LTC. And once those LTC are in the payment channel, it enables exchange A to send Litecoin in real time to exchange C, like this. Okay, that's the basic principle. Take it out of the public blockchain, put it into a payment channel, and then I can send Litecoin in real time because it's not recorded on the blockchain. It stays within the payment channel. All right, let's get a little bit deeper into the magic that actually happens when a payment channel is opened. So it's actually not a special wallet, that's just I just called it like that. It's actually a 2-of-2 multi-sig address. What that means is it needs signatures from A and B for any funds to be released. And the deposit is called an opening transaction. So an opening transaction is an on-chain transaction on the Litecoin blockchain into this 2-of-2 multi-sig address from both sides. That's what it is. And in the second step, exchange A and exchange B think of a secret and then hash the secret. So we have an A secret and a B secret, and then it gets hashed by them and they send it to each other. Again, they send the hash of the secret to each other, not the secret itself, just to make sure. And in a consequence step, and that's how it's done in practice, immediately the commitment transaction follows. The commitment transaction itself is the actual 1 LTC that is flowing from A to B. So in practice, it's not that I'm opening a channel and then just wait and do nothing. I'm opening a channel and immediately send my first transaction. That's how it works. So the commitment transaction consists of 2 parts. So exchange A creates its commitment transaction. 2 parts. Number 1 sends 99 LTC back to itself. And number 2 sends 1 LTC to a little bit a funky multi-sig address. And this 1 LTC transaction includes the hash of B secret from exchange B that it got received before. So why is the second multi-sig address a little bit funky? Because it has a characteristic that the funds in this wallet can be only unlocked based on 2 conditions. Number 1, it can be unlocked by B after 1,000 blocks, after a certain time. So just if this time passed, then B can immediately get the funds of this in this multi-sig address. Or it can be unlocked by A if B told A the secret. 2 conditions. So we see, especially the second condition is very important. We'll come back to that one later. It's a kind of an insurance. So this is a commitment transaction. The commitment transaction is done. Exchange A signs it and sends it to exchange B. Exchange B does the exact same thing, but vice versa. So exchange B sends 99 LTC to exchange A and 1 LTC to itself, does the exact same thing. Signs the transaction and sends it to exchange A. So both are now holding these commitment transactions. And they could, so the only piece missing now is they just have to sign these commitment transactions, and they could literally go and broadcast it to the blockchain, and they both would get their funds. So exchange B would get 1 LTC, and exchange A would get 99 LTC. That's exactly what they want, right? So they wanted to exchange 1 LTC. But the thing with payment channels is they could broadcast, but they don't. Right? So these commitment transactions, so the key technology in payment channels is I have perfectly valid transactions that I could broadcast to the blockchain at any given point of time, but I don't. And this is how I don't have to wait for any block confirmations at any time, and this is how I can transact value in real time. Does that make sense to you guys? So I have valid transactions in the payment channels that are literally valid if I just put them on the blockchain, but I don't do so because I want to keep the channel open and keep on transacting. But I can totally rely on it because I have a valid transaction, exchange A has a valid transaction, exchange B has a valid transaction, and they both can be rest assured we have valid transactions. All right, instead, they do the very last step in order to open a payment channel. The original opening transaction gets signed and broadcasted to the blockchain, and our payment channel is open. So this is the real magic that's actually happening. And you can see the status already is exchange B already received this 1 LTC. So by opening a payment channel, I already automatically execute my first payment. Okay, that's how bidirectional payment channels are open. And a couple of general characteristics about payment channels and why we believe they're great is because of the fact that they're built on top of public blockchains like Litecoin, like Bitcoin, and also like Ethereum, is they inherit the full security of the underlying blockchain. So simply because of the fact I'm able to broadcast these commitment transactions at any time, I'm secured by the underlying blockchain. That's also why, for example, Laru from MING Labs in San Francisco, he calls the underlying blockchain a dispute mediation system. So only in the case if something goes wrong or one of the two parties is not satisfied with what's going on in the payment channel, stuff gets broadcasted to the blockchain and then both get their respective fund. So only in case something gets wrong, we use the blockchain. If both parties behave honest, we're good and the channel can stay open infinitely. All right, this is a real beauty about payment channels. Payment channels support routing. So one can imagine, since a payment channel in comparison to a public blockchain is only a direct channel between two parties, I cannot send funds to everyone because I only have a payment channel to one other person, right? But payment channels support routing. That means if I'm, for example, here, this user, and I have a payment channel through my exchange open, and I want to send funds to A, then exchange C doesn't have a payment channel directly open with exchange A. But exchange C has a payment channel with exchange B, and exchange B has a payment channel with exchange A. So what I can do is route the funds through exchange B, just like data packets on the internet. So this is where it really clicked on me personally, for example, when I understood that I can route payments through multiple hops over the internet, just like our data packets in the internet. This is where I thought, okay, wow, that's actually something really thought through. All right, so now we're in a state where we have payment channels open between the two exchanges. It looks a bit complicated, but actually it's not. So we have two exchanges. They are running our XU node, our software. Exchange B also runs XU node, the software. They are both aware of each other's orders, the global order book, that's how we call it. And they have payment channels open to each other, here on the Litecoin blockchain and here on the Ethereum Classic blockchain. So now they're able to send Litecoin instantly to each other and Ethereum Classic instantly to each other. That's great, but one thing is missing. We talked about trustless before, and this is a term that sometimes is a little bit hard to understand, especially for non-native speakers, I have the feeling. So trustless is a good thing. Trustless means exchange A doesn't have to trust exchange B. But at the moment, what ensures exchange A that after sending its part of the trade, the 10 LTC to exchange B just disappears, right? Takes the funds, walks away, says thank you, and that's it. At the moment, there's nothing in place that avoids this. This is exactly what atomic swaps do. So atomic swaps, very simply put, enable the trustless exchange of two different assets without any middleman and without any escrow service. And how they do that is they guarantee the atomicity. This is where the atomic term comes from. Atomicity means both sides of the trade happen or not at all. If I send 10 LTC from A to B, then also 20 ETC go from B to A, or nothing happens. And the technology involved here is called hashed time lock contracts, or short HTLCs. And now it gets really exciting. Now we talk about how these HTLCs actually work. So we know that it's like one of these buzzwords next to blockchain, but actually not a lot of people actually understand what that means and how they work. So let's go through. So exchange A thinks again of a secret, and then hashes the secret. And then this hash gets included into a transaction of the 10 LTC, which it sends to a lockbox. So this lockbox, really imagine it like a box where I can put funds into, and this box only opens until I meet certain conditions. So this lockbox is configured in a way that it only opens if I input a secret and the signature of B. That's how it's configured. Okay, that's where the term hash lock comes from. So basically a hash lock is a construct of a transaction that says fill in the blank, and if you fill in the blank, then I unlock the funds. Right? That's called the hash lock. This is the hash lock part of the hash lock time lock contract. Exchange B does the same thing. It includes the very same hash of the A secret into a transaction of the 20 ETC, which it puts into a B lockbox. And this lockbox is configured in a way that it only opens when I input A secret and A's signature. And that's a key of atomic swaps. Both lockboxes need the same A secret to be opened. So before, when we talk about payment channels, both had their own secrets. Now, both of the lockboxes are configured in a way that they need the same A secret to be opened and the funds to be released. Let's continue. So now A wants to get its part of the trade, the 20 ETC. So what it does is, it reveals a secret, its secret that it created before on the payment channel, signs it, and like this can open the lockbox and get 20 ETC out of it. But the term reveal already implies B now knows a secret and is like, thank you for telling me a secret. Now I can go and get my 10 LTC out of the lockbox because the condition is a secret plus my signature. And both of their funds. That's pretty cool, right? So we just skip the need for an escrow service, for a bank, for any sort of middleman, and trustlessly exchanged two assets. Because as the very last thing, if one of the parties during this whole process drops that, disappears, whatever, something goes wrong, then there's a time lock involved. I didn't mention that before. So if something goes wrong, both get their funds back. This is the not at all part of the atomic swap. Okay? So even if exchange B just disappears, after a certain time, both just get their funds back, and that's it. So worst case, funds are just locked up for a little bit. All right. So hash time lock contracts exist on all major chains. On Bitcoin, it was included via BIP 199. It's on Litecoin, natively integrated, and in form of smart contracts on Ethereum. And now we're going to demo this. So we have Anchor here, which successfully completed an atomic swap of ERC20 tokens on the Raiden network, which is like Lightning, which is the payment and integration on top of Ethereum. And we do it live. Let's see if it works, if our internet brought from China is strong enough to support everything. Anyways, we're gonna try, and if you wanna try on your own, we have a detailed tutorial, a write-up of this whole process that's gonna happen now on our blog. You can just click on it and do everything on your own and verify your own success. All right, Anchor.
Okay, thank you, Gillian. My name is Ankur, and I'm a blockchain developer at Exchange Union, but we are a startup, so I wear all the hats right now. So I don't know if you guys paid attention. Gillian talked about this stuff called payment channels. How many guys actually got that? Like, how many of you now know what a payment channel is? Like, should please raise your hand? Yeah, awesome. What? Why do we need payment channel? It's because blockchain is slow and it's expensive, right? And don't worry about this happening right now. I know a lot of people from non-technical background might find this very intimidating, but trust me, soon you won't. So why do we need payment channels again? Because blockchains are slow and it's expensive, right? So we want a way so that exchange A can trade with exchange B instantly in a jiffy. So payment channel just enables that. It enables me to trade with you very instant and very quick, right? So for payment channel to work, we need to open a payment channel, right, between A and B that Gillian talked about. So I'm going to just like show you guys that how you can actually open a payment channel. You can do it right now. So there you go. Okay. So this is the rating network that enables creating and opening a payment channel. Yeah. So right now, what you're seeing is like a sort of a UI, that is a user interface. As Dylan talked about before, a lot of put APIs and stuff, a lot of put, get, and post requests. It is exactly the same, but it's just built on top. Yeah, it's a user interface that is built on top of it, so it's very easy to use. You don't have to get into the nitty-gritty of APIs. So as you see, to open a channel, if I want to open a channel with you, the first very thing we need is the address of your node, right? I want your address because I want to open a channel with you. So this is the partner address that I put in there. And second thing I will need is the name of the token, what I want to send you. I want to send you Bitcoin, or do I want to send you Litecoin, or what kind of token we want to send you. So this is the address of the token that we are going to open the channel for, right? Which we'll put the deposit for. This is the one token that I deployed on Rockstone testnet. It is one of the Ethereum testnet. So I deployed that. And how much of those tokens you want to deposit on that channel. So this is just the depositing amount. And the settle timeout period is, just settle the channel after you're closed. There's a certain amount of time that you have to wait before you can actually settle the channel. So you just do this, and you say open, you click on open, and after some point, you will see that this is actually a blockchain. What you're seeing right now is a Rockstone testnet blockchain. And you will see, if you guys could like pay attention, you will see here that transaction mined, right? That some miner has mined that transaction, and now I have a channel open with you, okay? Which you will see in a Zippy in UI as well, that here, I have a channel now open with my partner, which is my second rated node, and which token was it? Is the one token that I deployed, and the balance of 10,000 of those tokens. So opening a channel is pretty simple. Right now on Rated Network, props to Brainboard who is developing this. So yeah, that is just as simple as it gets. You can like literally go out there and open a payment channel on the Rated Network with this very user-friendly UI, and you don't have to get into the nitty-gritty post get and put requests of the APIs. Now the second most important thing about that we talk about it, why do we open a channel? Because I want to pay you, right? Or I want to get paid. We want to trade, right? That is the one reason why we open a payment channel. So let's do that, right? I have a 2 Raven node open. I will do it live. I hope it works. Just okay. So you see right now, this is a 2 Raven node. I think you guys could see right now. This is Raven node 1 and this is Raven node 2, right? Think of it like just Killian said about before. 2 exchanges, A and B. A transfers to B or B transfers to A. Just think of like these 2 Raven nodes as 2 exchanges, A and B. Okay, so first thing first, we want to transfer. Okay, I would like you guys to pay attention to the channel balance right now. Node A, exchange A, has 8,999 of the ERC20 token, and exchange B only have 1, right? So if the payment is successful, what will happen is exchange A will have 8,998 of these tokens, and exchange B will have 2 if I transfer 1 token and it's successful, right? That is what we want to do. So it's pretty easy. We go to the token tab, we refresh the balance, we take the action, we say we want to transfer, we go to the second node, we take the address of the second node, we copy it, we paste the receiver address here, right? And how much we want to send of these ERC20 tokens? 1. Okay, we want to say 1, and we say send, right? And you will see in a while that token balance will actually be updated if the internet is working correctly. I hope it does, because you know this. Alright, I think the internet is pretty slow. I will just show you the video of it actually working. Okay. So here's the transfer token video that I had before. Alright, so we were at this point, and how it's supposed to work is like we put on like 1,000 of this token, and you will just see instantly that the transfer is completed, and the second node will now have 1 of those bitcoins. Right. Yeah. Transfer successful. 1,000 of the volume token address were transferred to the second node, right? So it's pretty instant. It happens in a jiffy. It's very, very fast, right? So this is one of the ways, one of the things that makes payment channels so attractive is the fact that transferring value is very fast, right? And the third part, which Killian talked about before as well, that atomic swaps, right? We at Exchange Union are using atomic swaps a lot. So why do we use atomic swaps? Because we want the trade to be very trustless. We don't want any trust in between the trades, right? So we want trade to be trustless. If I want to trade with you, I don't have to trust you, right? That's the whole point of blockchain and Bitcoin, right? If I had to trust you, I would probably use Visa or some services like that. Why would I use Bitcoin? So for atomic swaps to work, I also have a demo here that you probably guys can see. Yeah. Okay. So
hello everyone.
Here's the demo, and two Raven nodes just before, as simple as that. Before I told that, and give me a second here. I will just get to that point. Okay, so there is for atomic swaps to work, there's 2 roles. One of them is maker and one of them is taker. Right? Somebody has to make an order and somebody has to take an order. So first of all, my first Raven node, that is exchange A, chooses to be a maker. I click here. Let the box be filled and then I will explain it. Okay, so yeah, cool. So partner address is the address of my second node, like where I want to token swap with. So this is the partner address of the second node. Identifier is something that is a tag so that I can identify the Raven node below that where I have to send the transaction. Sending token is Bitcoin. It's not Bitcoin, it's Bitcoin. I want to send Bitcoin. How much Bitcoin I want to send? 1 of the Bitcoins. And how much, what I want to receive? I want to receive a custom token named OX6EE. A, right? And how much token, OX60 token I want to receive? 1 of it, okay? So here I define the maker load. Mind you, I will show you the channel balance before. What was it? Here you go. Okay, just look at the channel balance right now. Before the swap happened, I have this exchange A have 0 of the custom token and 10,000 of the Bitcoin. Exchange B have 10,000 of the custom token and 0 of the Bitcoin. After the swap is successful, what would we want? We want exchange A to have like 1 of the custom token and exchange B to have 1 of the Bitcoin, right? And one should be deducted from these two addresses. So we want that to happen, right? So let's see, after we do the maker role, we copy the string, we say that we want to swap, right? And we do same with here, we take the taker role and we do exactly the same and we reverse the whole order. Now the partner address is my first node, identifier is 1337, sending token is the reverse one of what we wanted to receive. It's now OXE6. We want to send 1 of it, we want to receive Bitcoin, and receiving amount is 1. And we confirm the swap here, okay? Here we go, and receiving amount is Bitcoin, and receiving amount is 1. We confirm the swap here, bam, right? And identifier is done. And now after that, you will see in a while, boom, look. Now the exchange 1 has balance of 1 of the ERC token, just like we wanted, and 1 of the Bitcoin is deducted. And exchange 2 has 1 of the Bitcoins and 1 of the ERC20 token is deducted. So we have successfully swapped the token, and blockchain does not even know about it, right? Because we never hit it. So it's not slow and it's not expensive. So that's why payment channel is so nice and so exciting, and that's why we at Exchange Union believe that this is the kind of technologies that we can use for the future of cryptocurrencies and to realize the Satoshi's original dream that we can actually trade with each other without the need of trust, and it will be very instant and very fast. Thank you.
All right, thank you. We just quickly finish up our presentation. There we go. All right, and if you remember, we have payment channels as key technology number 1. We have the atomic swaps as key technology number 2, and our third key technologies are the decentralized order books. And what that means is that each of the exchanges is running an XU node, and this XU node is maintaining a local copy of the global view of all orders that are available. So what happens now if a new order is coming in? For example, here in Exchange C, where somebody wants to sell 5 BTC for 10 C cash, what is a pretty good trade. Now this order comes in, the XU node picks it up and propagates it to its direct peers, the fastest way possible because latency matters. And they update their local order book and are now including this order information as well and can fill it. So the XU node takes care of propagating the order updates to its peers. And we also have already a system in place where we will be using our token XOC for rewarding special nodes which are relaying orders. Because speed matters, latency matters, and in certain cases it makes sense to go actually via another hop to speed up my order update to all the other peers. And also, very, very important, we use XOC to avoid the market makers, the liquidity providers. Those are the exchanges, the big exchanges that I mentioned before, which are basically contributing their liquidity to Exchange Union, to the network. So we want to incentivize them with XOC, which they get paid from the taker. So the taker pays the maker for the order. That's the key. And we have a couple of systems in place that take care that order spamming, avoid fake orders. So basically to take care that the network is not flooded with fake orders. All right, summary. Exchange Union is not a blockchain. This makes us very different from a lot of projects, nor is it an exchange. It's a technology which connects exchanges. And it's open source and it's decentralized. And we have three key technologies: payment channels, which make our trades instant; atomic swaps, which make them trustless; and the decentralized order books, which connect the buyers and the sellers. With benefits for both, for the exchanges and the users. Exchanges mainly through increased revenue for the big ones, or increased liquidity for the smaller ones. And the users, which can trade from one account and automatically get the best price. And as you see, our token is used as a fee and incentive system to incentivize certain stakeholders, for example, liquidity providers, or also, very important in the current stage, developers which are contributing to our code base. And at the moment we are in early development stages. We already have a rough prototype out there on our GitHub. And our next milestone is to have a detailed technical specification out there in order to ensure interoperability with other solutions. And we want to have a working proof of concept by the end of the year. And realistically, mainnet release on the three main chains, Bitcoin, Litecoin, and Ethereum, by mid of next year. So we believe Exchange Union is public infrastructure, so that's why we decided to make it available for free to everyone. And we also want to give a little bit an outlook what we hope and want to see happen down the road. We believe it enables entire new product lines. Like, imagine, for example, a wallet, which at some point in the future will be able to integrate the Exchange Union software directly without even the need for a third-party exchange, and directly swap any digital assets against any other digital asset directly from within the app, without the need for a third-party service, any central service. Or a merchant POS, where now a merchant is able to accept any sort of digital token and just settle it, swap it into, for example, Bitcoin, and settle everything in Bitcoin. So in the end, we hope that at some point we can contribute to promote financial inclusion, especially in emerging markets, by giving these services, like providing these tools to people that can use it directly without the need to go through a third party to get approved by a bank, provide identity or some sort of reputational documents. So this is a technology which can be used by everyone. All right, that's it. Thank you. Feel free to connect with us. We are hiring as well, so we're always searching for skilled blockchain developers. Today we have our HR manager, Kerstin, over here. So if you think you want to leave your details over here, connect with us, please do so. Feel free to check our GitHub, so the slides will be on there as well, our Telegram group, and we also constantly post updates on our Twitter. Thank you.
All right, thank you, Keelan. How are your bladders holding there? Thirsty? If you guys want to have some drinks, want to use the toilet, we have a 5 minutes break. Don't go away yet. We still have Eric Wood. Eric will be talking on Zero Proof. Interesting concept. So, go for it. We will have a Q&A session towards the end, so don't leave so soon, yeah?
So from the Ethereum transaction ID, I can load the shop address, send the X token to a destination address. But for a Dash system, there are some type of transaction can help you to hide the destination address with a zeroing transaction, or some type of transaction help you to hide the source address with a dezeroing transaction, or even hide the all transaction information, source address, destination address, and amount transfer is a zero transaction. So it seems quite fascinating from a technology perspective, but it's quite pretty scary from the money laundering perspective for the cash system. And this innovation is truly in terms of the zero knowledge of proof. And then zero knowledge of proof, the technologies help us allow a transaction fully encrypted and still validate it. So we can see that from the recent Ethereum Metropolis update by Jenkins occurs on the 16th of October 2017. So Ethereum Foundation, the DK block is a cryptographic tool developed by the Zcash team. So what will we use for? Okay, the first thing that we need to understand. Okay, the first thing that we need to understand what is the zero knowledge of proof. So, okay, the zero knowledge of proof is a very simple idea. That's the method or process. The one person prover to prove to another person that some statement is true without revealing why it's true. So I think a lot of talk shows they are using the use case to the two color different code to demonstrate the zero knowledge of proof. But for here in the blockchain developer community, so I will explain in the programming context. Thus, I have a program in C. So now I need to prove that the computer A need to prove that to the computer B that A have a solution X for every specific input X. So without revealing solution X for the computer B. So okay, it's super simple idea. However, when you implement it, you need to develop a three main key algorithm for the ZK slot. So first one is the key generator. This one will take the secret parameters and then the program is a program C you want to prove, and then it will generate the proving key and verification key. These two public keys will only one time generated and given by program C. Okay, so the next step, the prover will take the proving keys and the public inputs and the private witness. So it will generate the proof. Thus, the proof will know the witness and the witness secret program. Yes, this algorithm. And the next one, the verifier. So now the verifier will run the verification algorithm. So so it will run. You take the input verification public input key and public input and proof. This proof is generated from a prover. So it will return true if the proof is correct and false otherwise. So if it return true, it means that the prover they know a solution. The witness certify that S will equal to CSS. So here the three main algorithms you need to learn how to prove. Okay, so now we need to understand how using these space block on Ethereum. So I let's review how the Ethereum processing a transaction. So when you publish the transaction on Ethereum, so the transaction will transfer to all miner, and on the miner to solve the proof of work puzzle and execute a transaction. This one we call the on-chain process because the transaction process on the Ethereum. We also have concept of off-chain process. This means that the transaction will process as a local host, and then Ethereum miner just verify the results. So now how we are using the ZK block onto Ethereum. So you can imagine that for this case, the transaction sender will be the prover, and then Ethereum miners will be a verifier. So the generator will run off-chain to produce the proving keys and verification key. And then the next step, any prover they can using a proving key to create a proof. And then the next step, the verification will run on inside a smart contract algorithm. So this one we're using to trigger another on-chain activity. It's the main, here the big picture for how the ZK block work on the Ethereum. So any question about it? Okay, so I can go ahead. So when you implement the ZK block, you need to meet the four standards. The first one is that the prover, able to convince verifier, Ethereum miner, that some statement is true without revealing why it's true. The second one is the 16. This means that the Ethereum, the verification algorithms need to compute it in amount of times, especially for the verification algorithm, because this algorithm will run in the on-chain. The next one is a non-interactive. It means that the slot doesn't require verifier to interact with the proofer, and in advance the proof, they can publish the proof. And the verifier just make sure that it's correct. Argument of knowledge. What does it mean? So this means that the outcome of verification process have a show of the proof of knowledge of some computation. So now you can see that the ZK block is stand for zero knowledge, 16 non-interactive argument of knowledge. Next. Okay, I will explain in the code level. I'm not sure that you can see this of the code here. So here is a Japanese basic token smart contract. I use this smart contract for the all of my ICO projects. So I think that is so familiar with all of you, because when you develop the ICO smart contract. So now, if I want to using the ZK slot and develop the one token smart contract, thus the all transaction value will be hidden on the Ethereum. So here's how I do it. And there are some different you should notice here. The first thing that the balance now is from address to integer, is the mapping between address to integer. So in this case, you can mapping between the address and the byte 32, because the transaction now, because I only store the parent hash, if not the parent. The second thing, the transfer function. Now the transfer function, we don't do any computation here, such as subtract or add the value for the receiver or sender. Instead, we are using the sender approval and the receiver approval. This one, the verification algorithms run on Ethereum. And then the outcome of this, we are using to trigger on-chain activity. Yeah, so this one will update the balance hash of the message sender and update the receiver hash from the receiver. Yeah, so. Okay, so now we need to know why we need to learn what the ZK spot. The first thing is we know that Ethereum transaction is very costly. Yes, when I do the ICO project, so one of the tasks. Yeah, so one of the tasks I need to import the wireless address into the Ethereum smart contract. And each time I only import maximum of 300 address, because the Ethereum block, they have a gas limit of 7 million gas, so you cannot do much high computation on the Ethereum. So with the ZK block, you can do this high complex computation at the local host, and then you make the Ethereum smart contract that verify it. Yes, this is a way to solve the high complex computation with the Ethereum smart contract. The other way is that if the cost verification is cheaper than the cost execution, so the ZK block can help you to save a transaction cost. The second aspect here that ZK block can help us to share and use the data on the Ethereum. Okay, so any one of you here have experience to building the app on the Hyperledger Fabric one? Yeah. Okay, so I think next time I will do some workshop on the Hyperledger. So Hyperledger Fabric, they also claim that they're able to solve the privacy data on a blockchain. So in order to protect the data between party A and party B on the Hyperledger, they will create a new channel. And then new channel means that create a new data chain to store data. But for the Ethereum, they are using a ZK block. So from my point of view, I think a DK stock is the more decentralized and more interesting concept. Okay, here are some use case you can apply for the DK stock. So you can using it for proof of you are the owner of private keys without showing the private key. Or you can using that for proof of someone belong to a membership of group and without revealing the identity. Or can using a balance check for the available enough for balance hash. Yeah. So next one. And here are some online resource reference. You can learn on how the zero knowledge proof. And the most interesting though. Okay. If you cannot, so you can go to my communities. Yeah, so I'm the founder and admin of these communities. Yeah, so it's a Vietnamese blockchain developer. Yeah, there are a lot of good Vietnamese blockchain teams, such as from Kuiper, Gito, or Thamao. We are welcome you to go to discuss with us on the blockchain technologies, yeah, Ethereum, XDB chain, or Hyperledger. Yeah. So that's all. I would like to end my presentation here. And if you have any question on the ask about ZK stock.
Thank you, Eric. So I know you all have like burning questions you want to ask. When we ask the speakers to come on stage, we'll have a very quick panel discussion to answer some of the questions that you might have.
So this is a question to Dylan. Thank you very much for giving a very detailed explanation of how exchange union works. So the question is this, right?
Yeah.
How does exchange union differ conceptually from commit that is developed by that is being developed by 10x?
10x does develop a crypto card as far as I know, right?
They're working on commit, COMIT.
CMOIT. Okay, I don't know about this project, so you have to teach me what it does so that I can say how it differs.
Okay, I was hoping you could tell me something. Okay.
Sorry, I don't know this project.
Maybe you could look it up. They have a white paper.
Okay, sure. Cool.
10x is in Singapore.
I know, yeah.
And the boss is Toby.
We'll get back on that. Any other questions pertaining to the presentation today?
In your talk you mentioned about payment channels, and then you mentioned like cross exchange. So are you going to create payment channels with each exchange for each asset?
Yeah, very good question. In the beginning, we might do so, but as you might remember, I talked about routing before. So we don't require an exchange to open a channel with every other exchange for every asset. So it's simply possible for the exchange. Let me start like this. Our XU node is part of the official Lightning Network. It's a sub-part of the Lightning Network. It's part of the official Raiden network. So the exchange can leverage this network to send payments and also route payments through other participants of the network. So there's no need for a direct channel between each of the exchanges for each and every asset. They can route it through existing ones.
Sorry, I didn't mean exchange to exchange. I meant that you as a middleman, even if it's a curse word, you as a middleman are going to, what's your added value? Is it the only thing that makes sense is that you are creating payment channel with each exchange, like being in the center of the, like...
No, that's not the case. So we took very good care that we're not the middleman. So we really strictly follow the principle of 100% decentralization. Means there is no exchange union server or node in the middle, and which opens payment channels to all participants. Participants open payment channels with each other. So we really only provide the software, and exchanges run the software and open payment channels with each other. There is no exchange union server or node or payment channel generator in the middle.
What's the token for, your token?
It's used for setting incentives. So we are setting incentives for liquidity providers. So someone that has a lot of, usually it's limit orders, right? So if I have a lot of orders in my order pool and I open them, I feed them into exchange union, so to speak, I get rewarded for that with XUC, with a token. So we have the basic principle of the taker, which takes liquidity, which uses the liquidity, pays the maker, which provides the liquidity. Why is that? It's because exchanges work according to this principle today already. Exchanges incentivize market makers. Usually they do so by having either a lower fee or even 0% fee for a market maker. That's exactly the same principle we are following in exchange union as well. Just that the taker is directly paying the maker. Does that make sense? So it's used for incentivization of providing liquidity into the
yeah,
system.
it does, but it looks like it's utility token and it's someone.
It's a utility.
I don't know.
It's a utility token.
It's like I fail to see an added value of your network. Are you familiar with Stellar and
Right.
anchoring and hash locked transactions and all that stuff?
Right.
They are covering what you described. They're covering it on protocol level, on core level.
Right.
So I fail to see any sense here in your case.
Imagine you run an exchange. Imagine you are the owner of Binance. Why would you join Exchange Union? As Binance, probably you would not, because you only see that you can lose trades, that you actually only can lose liquidity, right? So others are taking away your liquidity, which is your unique selling point, right? So we want to incentivize the big exchanges, which are very important for us. Exchanges are our #1 users, to provide the liquidity to the network, and this is what we use the token for. So the primary use case is really reward the exchanges for liquidity. Otherwise, large exchanges don't have a real reason to join, if that makes sense. And in the current stage, we use it to build up the system itself. So we use it to incentivize the developers, for example, that are contributing code. Yeah, so we have the advantage that our token is already out there, it's already being traded, and it already has value. So we can use it to build up our ecosystem right now. And in the second thing, so not only liquidity providers, there's also some sort of technical services that have to be provided that are related to payment channels. So we use payment channels, right? So payment channels have a couple of value-added services which need to be there in order for the whole thing to work. For example, you might know that if I have a payment channel and I just go offline for a while, malicious stuff could happen. So I need something like a watchtower. I need someone to basically watch the blockchain for any malicious transaction to happen. So this is a service we intend to also award with XUC, with our token. So we intend to use our token to actually incentivize the growth of the Lightning Network and the Raven Network.
This question is for Eric, and you talked about zero knowledge proof. And thank you for the very good, detailed introduction to zero knowledge proof.
Yes.
The question I have, Eric, from a layperson's point of view, how will you explain simply and cleanly for a layperson what is zero knowledge proof? Number one.
Yeah.
Number two, why is it necessary? For example, I hear that I believe either Zcash and Monero is better than Bitcoin because it preserves privacy thanks to zero knowledge proof. So can you explain layperson's point of view, zero knowledge proof, and why is it better than Bitcoin in terms of preserving privacy? Thanks, Eric.
Okay, Ken. Okay, I think it's a question. The first thing is that the most you can, for you can know the different, what's the zero knowledge proof you force. For example, you have a true color proof. So you with a different color, you actually the knowledge you learn from that someone the true color proof is different. You don't need to know exactly why the color is red proof. So okay, why the red cash should be better than the Bitcoins? Because from the transaction ID from the Bitcoin, so you can trace the source address, send an X token to the destination address. But for the red cash system, you send a transaction to the encrypted address, so you don't know exactly what is the address you send for, or even though you can encrypt the full transaction. Okay, so some use case you can, okay, the benefits from the zero knowledge of proof. Thus, okay, you see the way you should do the verification smart contract, the verification algorithms will run inside the smart contract. So now the execution it will run as a local. So this way, if the cost of verification cheaper than the cost of execution, it will help you to save a transaction cost. The second thing is you can verify some computation without revealing why and how run it. So it's a way to help you to share and use the privacy data on the Ethereum. So, it answers the question? Yeah.
I will have to look at the list of references you gave and look into it and read more into it. Thanks.
Okay, thank you.
Good. Any more questions?
Yeah, this question posed to the Exchange Union. So you say your platform trying to find the best deal for your user. So is this still a smart contract on peer-to-peers? And second question is that you say your token is a utility token, but I cannot see for the whole transaction, your token is a media of this transaction. So how can it be a utility token?
Okay, maybe the last one first, the meteor. So what we didn't want is to force usage on the token. For example, we didn't want the token to be an intermediary currency. So a lot of systems, for example, let's say Ripple, work on the base where they use their own token as an intermediate currency. So we looked into that actually in the beginning and also considered doing that as well. So whenever there's a transaction happening, we use XOC as an intermediary. Why we think that it's not really reasonable is because it's indeed a forced usage. And the questionable success of Ripple actually shows that. So when I start, for example, with Bitcoin, I have to go into XRP, into Ripple, and then I transfer the value, and then from XRP I have to go back into whatever other token, let it be Bitcoin again. This doesn't work because I need really liquid markets on both sides to be able to actually buy and sell on both sides accordingly. And if I don't have these liquid markets, it doesn't work. So for high volume transactions, actually, I totally understand why banks don't want to use that system, because they basically are not able to buy and sell XRP in the amounts they want to. And it's really hard to create those markets. It's a super hard task, right? So it's solving the liquidity issue. So why we chose to use it purely as an incentive/fee system is because it makes the most sense. So we try to learn from Bitcoin in the sense of Bitcoin sets right incentives with the monetary policy to provide certain services, like mining, for example. So mining is very essential for Bitcoin's security, whereas for our system, liquidity is the essential part of the whole ecosystem to function. So we want to set the right incentives with our token to create this, to create the liquidity, and also to create the software and to create all the services that we need in our system to function. That's why we decided to make it a incentive system. What I believe is a utility token, but maybe our understanding of utility token is different.
But at the moment in time, your token have no value at all. How can you incentivize the user? Because you do not generate any income, like Binance, the exchange, they make money.
Our token has value. That's a luxury situation we're in. So it's already on exchange. It's being traded, so it has a certain value. So we can actually. Right. But yeah, that's with all tokens. That's with all tokens the case, I guess. Right? So yeah.
Peer-to-peers and smart contract, because you say you're not a blockchain.
Right. So yeah, you could call it a smart contract. So a payment channel indeed is peer-to-peer. It's always directly between two parties. And in order to execute the atomic swap, it's actually a smart contract, I can say. This HTLC, this hash time block contract, is, in my opinion, a smart contract. Just that on Bitcoin you don't call it smart contracts, you call it like it's an opcode, like a different sets of opcodes that are used. But yes, an HTLC is a smart contract, and it works on Bitcoin, and it works on Litecoin, and on Ethereum it's an actual smart contract. It actually runs on a real smart contract. And yes, it's peer-to-peer, only between two parties. So each and every trade happens exactly between two parties. And only these two parties actually know about the trade and know about the transactions and the amount and every detail that is going on. The rest of the network doesn't know. Did that answer the question?
Okay, the peer-to-peer will go to the third party, the other exchange.
And the routing, you mean?
Yeah, right, because there's no direct exchange. How do you account for that medium?
Okay, so that's really cool what Lightning did there. I'm actually not too sure how Raiden does it, but I guess in a similar way. So there's something called onion routing. So the intermediary exchange, for starters, it's taking care that it can't steal the funds. So if I'm routing a payment, let's say I want to make a payment to him, and I'm routing it through him, then it's taken care through cryptography and HTLCs itself. It's an actual HTLC that takes care that he cannot steal the funds on the way. That's number one. Number two is onion routing means when he opens the packet, what he sees is sender and receiver, but he doesn't know who's the sender, if it's the initial sender or the final receiver. He just knows that he's a hop on the way, but he doesn't know that I'm the originator and he's the receiver. So onion routing takes actually on Lightning Network, that's what I personally like read about the Lightning Network, about the privacy aspect, that the intermediaries don't know what the senders and the receivers are. They just know, okay, I'm an intermediate hop between this and this person. If they are the final receivers and the final senders, I don't know. It's like BitTorrent, the Tor network works the same principle with onion routing. That's what Lightning does. It's actually pretty cool. So yeah, privacy is taken care of, and the intermediary can't steal funds is also taken care of.
You told that your system is not a blockchain. But it's kind of blockchain because you have order books on all nodes, and every node have a copy of the order book and should update it periodically. And it's kind of a private blockchain. Yeah.
We thought about it, so we thought, hey, we could put all the orders on the blockchain and order them in the fee system. But in the end, what it comes down to is latency. So if you put orders on a blockchain, like for example, Loopring does, what is an amazing project by the way, they put orders on a blockchain, they have actually a fee attached to the order, so a totally different concept of how orders are sorted and incentivized. That's cool, but it won't work for us because exchanges don't work that way. Exchanges work in the way whoever sees an order first is able to fill it. So basically they have the advantage of having information earlier than others. So why we can't use a blockchain is because it's simply too slow for us. So a 15 seconds confirmation time on Ethereum would be, it's a lifetime in a day trader's world, right? So that's why we cannot put orders on a blockchain. So our order book information exchange is completely off-chain with a direct peer-to-peer socket connection. Right? So it's traditional internet technology, how the actual order book information is exchanged. They're still signed and there's signatures involved, but it's a direct information exchange between two parties.
And how about the consensus about order book?
There's no consensus. Because it would take time as well, right? Think about it. An order book consensus would take time for all participants in the network to come to a consensus and say, okay, this is a valid order and he gets the order, right? So this would take, again, time. We could do that, but it would totally break the experience that we are currently having in centralized exchanges. On a centralized exchange, I'm used to click the buy button and a couple of milliseconds later it shows filled. Usually, if there's liquidity, right? But in general, the technology is capable of it. If we had a consensus algorithm, what comes with a blockchain usually, we would have like, please wait for BlockFile to confirm, or please wait for consensus to be reached. This is something we cannot do. So what we decide to do is, we give the full power of an order gets filled or not to the maker. So the maker is the only decision maker that says, decision maker, that's actually a nice analogy. So they is the decision maker that says who gets the order, and all the rest gets rejected. very good question.
So I guess a three-part question, so hopefully I won't too many, really about the Raiden network. One, is the Raiden network complementary to the Lightning Network? Is it connected to the Lightning Network, or is it separate? And is Raiden/Lightning, how many transactions are going across this network now? And I guess the third part is just a second layer off blockchain. What are the events that take place that actually require you to go on-chain to the first layer?
Okay, cool. First thing is Raiden is Lightning on Ethereum, literally, right? So payment channels, aka state channels, are Lightning is the implementation on Bitcoin and Litecoin, Decreed, and a couple of other Bitcoin-related chains. And on Ethereum, it's called Raiden. It follows to, Anchor help me, maybe 90%, it's exactly the same like Raiden. The only difference on Ethereum is, since Ethereum doesn't have UTXOs, they deal with balances. But the basic principle is like Lightning, and they have the same characteristics, the same routing mechanism, it's all the same. So to answer your question, Raiden is the Lightning on Ethereum, period. And it's developed by a company called Brainbot mainly, so they are the guys that are behind it. Lightning is a little bit more diversified, so Lightning is developed by 3 companies, so you have 3 competing implementations, and the great thing is they're all compatible. So you can use them among each other. It's like having a Bitcoin D, BTC D, and I don't know, another full node implementation of Bitcoin. We all can send Bitcoins to each other because they follow the specification of the Bitcoin network. The same is happening with Lightning at the moment. But I think it's great because I can choose. Right? And the second question was something again?
So second part was the number of transactions taking place on, I guess, Raiden/Lightning. I hear a lot about Lightning, but I really haven't heard usage.
Yeah, it still hasn't been on mainnet right now. It's still in the testing phase right now. So these are all new technologies that are coming to solve the issue that we have with Bitcoin right now. That if I want to send you Bitcoin, it's so expensive, right? So these are all new technologies which are coming up so that we can actually enable, instant transactions when we do. So very early stage, they're all testnet. Nothing is on mainnet, so zero transactions.
Right, so real transactions very limited at the moment. So Raiden, as Anchor said, is still not on the mainnet. For Lightning, it's a little bit different. So Lightning is unofficially already on the mainnet. So we have more than 1,000 Lightning nodes already on the Bitcoin mainnet, and a couple more even on Litecoin. And there are a lot of transactions going on. But if you're asking for the capability, whatever your internet bandwidth can do, right? So it's literally only limited by your internet bandwidth, and that's great. Right, so it's capable of Visa, MasterCard combined plus. Hundreds of thousands of transactions per second, no problem. Whatever your internet can do.
Yep. And the third part was the events that take place that require you to go from the second layer to the first layer blockchain.
Right. Dispute. Whenever one of the 2 parties says, I don't think this channel state, so my balance is the correct one, then I basically take my commitment transaction, maybe remember this commitment transaction, say this is a valid one, and throw to the blockchain. And then there's a mechanism in place where the blockchain knows, so then party A, so let's say party B says, I don't agree with that, this is the right channel, the right balance, throws it to the blockchain, gets broadcasted, then there is a time lock involved that gives party A time to broadcast its opinion onto the blockchain, and then the blockchain knows through cryptography which one of the 2 is the valid one. It's 100% clear. There's no chance that both of them can have like a, that there's no solution or something, that there's no, no decision can be made. It's always clear.
Like in conditions when there is no dispute. Okay, so let's just see, like I opened a channel. The first thing I did, so I opened a channel and it went on the blockchain. Okay, so I opened a channel with you. Blockchain knows that. Now I have a channel. I can send you money, receive money very, very fast. Blockchain does not know about it at all. And the end goal is when I close the channel, blockchain knows only the first and the last thing. So that, okay, it started from here, ended here. It does not know how many times I send and how many times I receive the data. That's why it's so instant and so fast, because we don't have to make the blockchain every single time. So that's the gist of it. Unless there's a dispute, unless we have to open and close the channel.
So it could be a dispute to close the channel, that's when it hits the blockchain, or it could be actually a common agreement where we just say, hey, we're not friends anymore, we want to end our relationship, and we just close the channel. Then it also gets recorded on the blockchain. Those are the two events where it hits the blockchain.
Thank you.
Great, more questions, guys? I do want to remind you there are other speakers as well that gave Dylan on the API, and Rama is talking about crypto.
I would like to ask Raman, like, first of all, props for making crypto job left. I've seen that in person as well. It's incredible, and I've been there a lot of times. So, how do you plan to scale that? Like, right now, the market is awesome right now, so it's very easy. So, I'd like your thinking process. Like, how do you plan to scale that to say what? Whatever you have right now, 10x that. How do you plan to scale that?
Okay, thanks so much. Well, one job at a time, I guess. Yeah, for those who don't know, we got like really crazy like growth in the past several months. Yeah, just right now it's me, and I'm not really planning to add more people to the team. Maybe I will, I don't know. But yeah, right, just automate all the things. Provide some, some reputation mechanisms, perhaps maybe using blockchain. Maybe we'll do some reputation contracts on Ethereum. We'll see when people are, trying to build. Like one of the biggest problems that we have, or pretty much the whole ecosystem has, is that there are a lot of companies out there that doing not very legal or not very trustworthy activities. And when they're hiring people, they promise tokens or whatever, and they actually never fulfill their promises. So like figuring out who is the honest company, who is the honest employer out there, is some of the things that we could, and as well as who has the actual skills to fulfill certain position. This is some of the things that we might be able to solve with, maybe like proof of stake, that like people some stake some coins if they claim that they have enough funds to pay talent, or the talent has claims that they have the skill to do the job. Maybe both sides will be able to stake some funds, and after a certain given point of time, our ecosystem and our community will be able to support, of course, who are the good, filter out who are the good players versus who are the bad ones. It's just the ideas. Thanks so much.
I have a question from the guy that gets a snapshot from Bitcoin blockchain to SQL. I was outside and I don't hear well. I want to know, do you check because Bitcoin transactions have sometimes several receivers, but in your table I see only one receiver. Do you cover other receivers as well in the transaction? This is the first question. And the second question is that you told that it takes 5 days to query the blockchain and update the SQL. Is it the final Bitcoin blockchain till that date? And I want to know, is there any public location for finding the SQL snapshot or something like that for queries, for tests and like that? Can we access that?
So for the first question, what's about
several receivers?
Oh yes. Normally, how Bitcoin works is, if I have 10 Bitcoins and if I want to send 7 Bitcoins for you, I will be the sender and you will be the receiver, and once I send the transaction, the rest 3 Bitcoins of me will be stored in a separate wallet. So that's how it works. So that's why I have a separate column in the database called balance receiver. So whoever that receives that balance will be stored in as a balance receiver in the wallet address. So all the way from the beginning to the end, I can track who is the sender and who is the receiver and who is the balance receiver. So that's how I managed to do that, those kind of several receivers. And actually,
so one transaction might have several lines in the database.
Yes. So that's how I managed to do that. And for the second question, actually, still I am converting all the transactions it's not 5 days. It's about right now. It's about 2 months. Yes. So because connecting from my script to the Bitcoin daemon, that connection is really slow for me. Because even though I am connecting using my local host and everything is in my local machine, connecting like millions of times to that node, it took me so many time. So right now I am converting like a speed of 500 transactions per second, but still it's not good enough to convert from 2009 to right now. How many transactions I don't know. So happening. So that's how right now it's going on. And later what I want to do is, so once I finish converting all the database, I will open source it. I don't want to keep it separate. And I have some plans to calculate all the wallet balances once I convert all the transactions into SQL, which will be pretty easy once I convert everything. So then I can sort all the wallets from their balances, and I can find who has who has the top values of in their wallet. So that was my final plan. Maybe I will write a blog post after that, mentioning all the wallet IDs in Bitcoin, how much this guy has and how much this guy has. So maybe later I will open some APIs for people to consume and check their wallet balances. Right now also you can go to some, if you know the wallet ID, then you can go and check the balance, but you cannot go there and check who has the highest amount in the Bitcoin wallet. So that's what I want to do, is kind of this fun project for me.
How much of the blockchain reached now?
Right now, when I checked today morning, it's passing 500,000 blocks right now. So it's like almost end. So today, when I checked, it was 2017 December transactions are right now happening. So it's a few months away.
And I had a question that you can figure out that how much balance every wallet has. But if a wallet enters to an exchange and comes out from like 5 different addresses, how would you know that which address belongs to which wallet? Like you can never know that.
Yeah, I don't know who is this guy, but
no, I mean even the addresses. Like okay, so there is one address, say OX something something. That address sent 10 Bitcoin to say Polonex, and from Polonex he sent 1 Bitcoin to some other address, 1 Bitcoin to some other address, 1 Bitcoin to 10 other addresses, right? So there is no way you can track that, okay, this coin came from these addresses and it went to like 10 different addresses, and I don't think if you put it into MySQL, there's any way that you can track. Otherwise, we would have found Satoshi already. I think so, yeah.
Yeah, that's true. If the guy who has the highest value of Bitcoin in his wallet is smart enough, he will not put all those Bitcoins in one wallet. So yeah, that's true. But yes. So if you remember the block transaction that I showed you that happened on 2011, I tracked him down to until like 20 transactions. What happened to this wallet? In the same day, in that 2011, he transferred that almost same amount from this wallet to around 20 wallets within like 2 hours. Maybe he wants to hide his wallet or somewhere. Then I just stopped querying that wallet. So there's something going on, like those kind of things.
We have time for one more very precious question. So if anyone has a question for any of our speakers today, this is your last chance.
Just continuing the questions just now, right? Are you literally, you said about breaking and initiating the network connections from your daemon? Are you literally initiating network connections and then breaking them?
No, yeah, kind of, yes, because I have to connect for each transaction to get those transaction detail, I have to connect to the daemon and get those transaction connections.
So it's not possible not to break the connection.
No, it's just HTTP REST API call, and then I get the transaction detail, and then for the next transaction I have to do another HTTP.
So is it possible to do things in parallel?
I don't know. I think it's not possible right now.
Do you literally have to go block by block in sequence?
Yes, block by block and...
In sequence?
I don't need to go, but for my script to automate, I'm going through the block by block.
So if you could do it in parallel, you could start, you could check several from different intervals simultaneously?
Yeah, that's possible, yes. Good suggestion.
But of course, your script, you have to figure out how to get everything together, how to aggregate all the results.
Yes, that's a good suggestion.
I think even if he goes in parallel, the resource is the same. He has the same amount of computation resource. So it does not really matter if he goes sequentially or he goes parallel, because the resource he's using, the CPU power, is the same. So if he goes like 1, 2, 3, 4, or goes like 1, 11, 2, 22, 3, 33, it's the same thing. Unless he increases his computation resource, then only he can increase the amount of time.
Are you talking about the Bitcoin?
Yeah, he was talking about how fast he is taking the Bitcoin block that is minus 2 lactose. Yeah.
No, you're talking about his client or the Bitcoin system?
No, his client. He has wrote a script that will take all the Bitcoin node and give it to the centralized MySQL database, right? Yeah. So what he's doing right now is taking one block at a time and putting it into MySQL database. But what you were suggesting is, why don't we do it in parallel? Like, why don't we do like 5 at the same time? We don't do it in parallel because the amount of computation resources are the same, right?
I don't think the limitation is on his mind.
It is on its mind, right? You have a certain amount of computation resource that you can use. So if he increases his computation resource, only then he gets mining faster.
My understanding that is that the limitation is on the Bitcoin.
No, it's not his one, because he's downloading it. Well, Bitcoin is already on the server. Everybody can download it. You can download it, I can download it. Unless I have more computation power, I will download it faster. If I have less computation power, I download it slower. So that's the point.
Well, the topic is really exciting, but guys, we do have a time that display shuts down. It will still be open for another 20 minutes, so feel free to approach any of our speakers, or make the best use of your time here. Network, exchange name cards, and I want to have one last more welcome applause for our speakers today. Thank you very much.